All right, section 8.4. Remember what I said. This is kind of one of those groundbreaking lessons. It's one of those where I call it a landmark lesson, where you can look back and you're like, oh, that's where I first learned that stuff. This is stuff that you're going to use quite a bit, especially if you go higher in your math, especially in algebra 2 or something like that. We're still dealing with right triangles. Remember, this whole chapter is about right triangles, isn't it? So even though the chapter is about right triangles, to tell you the truth, the next 2 lessons that we're going to do are not about right triangles. They're about something else. But this is definitely a right triangle. Now, if this was a 45, 45, 90, we learned some stuff about it, didn't we? Okay, we knew that the 2 sides were equal, the hypotenuse was the square root of 2 times one of the legs, and all that good stuff, okay? If I knew 2 sides of this right triangle, I could always find the 3rd side, couldn't I? By using what? If I knew 2 sides of this triangle, a right triangle, I could use what? Pythagorean Theorem, okay, to find the other side, the missing side, okay? What if this is not a 45-45? What if it's not a 30-60-90? What if I don't know 2 sides of it? Let's pretend I know that's 27 degrees. That's not one of my special triangles, is it? Okay, and let's say I knew just one of these sides. I said that that side was 5. Up to this point, would you be able to find the 2 sides right here?
Yes.
No.
How?
No.
No, not yet. You don't know how to find this side or this side, because this is not like half of this. This is not the square root of 3 times this, because this is not a 30, 60, 90, is it? So you can't use any of that stuff that we used with 45, 45, and 30, 60, 90s. You can't use Pythagorean Theorem. Why can't you use Pythagorean Theorem to find one of these? You only know one side. You don't know 2 sides. So right now we're kind of stuck, aren't we? We could find something in here, though. You could find the other angle, right? So you could find this, and that would be 63. Good. Yep. So you could find that angle right there. That'd be okay. But you still could not find either one of those 2 sides, could you? All right. So we need another way to do it, don't we? Now, there is a way. There is a way to find both of these other sides right here. But you don't know it right now, and that's what we're going to teach right now. Okay? Bet you're excited about it, aren't you? Now, you can't use a squared plus b squared equals c squared, because you know. That's right. Yeah, and that was mentioned before. All right, but that's okay. Watch, here we go. What I'm going to do, let's just name some of these sides right here. Let's talk about a certain angle. Let's talk about this angle right here. We'll just call this angle A. All right? What is this side right here? We already know the name of this side right here. This is the hypotenuse, okay? So I'll just put HYP for hypotenuse. Now look at this side right here. See this side? Tell me something about this side and this angle A. We really don't have any idea which one's shorter, which one's longer. We do know the hypotenuse is the longest side, right? But we have no idea because we don't know the value of the angles. But we do know, what would I call this side in relationship to this angle? It's what to it? No, we can't say short side. We just finished saying that. Who said that? It's opposite. Okay, it's opposite of angle A. So if I'm looking at angle A, this side right here is what? It's opposite angle A. So we know that word. We've used that word quite a bit. Here's one word we haven't used yet, but we're going to use a lot in this lesson. This side right here is next to this angle. We talked about this earlier in the year, though. We talked about two angles that are next to each other, which are adjacent, right? So this side right here is adjacent to this angle. It's next to this angle. We'll put ADJ. Okay, you spell it ADJ, adjacent. There we go. That's how you spell the word. But we're just going to shorthand it ADJ. Is that all right? Adjacent means next to. Some people might look at the hypotenuse and say, well, wait a minute. The hypotenuse is next to this angle as well, isn't it? But the hypotenuse is a little more special. Why is it a little more special than just a regular adjacent? Because it's opposite what?
The 90 degrees.
The right angle. That's right. It's opposite the right angle. Everybody see that? First of all, you got to know which ones I'm talking about. So if I'm talking about angle A right here, this side is opposite angle A, this side is adjacent to angle A, and this side is the hypotenuse. What if, I know it's a little chilly in here, sorry. What if I put angle B here? Is this side
Opposite angle.
Right, this side would not be adjacent anymore, would it? It all depends which angle you're talking about, right? So let's say we're talking about angle B. So, I know, just make another triangle. Draw another triangle. It's not that hard. Just draw another triangle. It's not that big of a deal. Okay? Oh my goodness gracious. Here, watch this. You guys are killing me. Killing me.
Killing you.
Yeah, you're killing me. Look.
Look, you know what? Just forget it. I already drew it on.
Look, this is angle B right here, and let's get rid of this. There we go. All right, I'm just drawing two separate triangles. You guys wanted two separate triangles, you got them. Okay, there they go. See, all for you. So that's hypotenuse. Now watch. The hypotenuse is always a hypotenuse because it's always opposite the right angle. Okay, so that's not going to change. But if I'm talking about this angle right here, what is this side now?
Opposite.
This side is opposite. It's opposite angle B. What is this side right here to angle B?
Adjacent.
This is adjacent. Okay, this is all very important for what we're going to do here in a few minutes. Okay, so it's very important that you understand which angle you're talking about, which side is opposite, which side is adjacent. Okay, are you ready? Now what we're going to do is this. We're going to talk, we got 10 minutes now. We're going to talk about a couple relationships. Listen to me. We're going to talk about some relationships between these three sides right here. Because you could compare them all kinds of different ways. What if we made some ratios and you compared two of these sides? I can compare them all kinds of different ways. In fact, I think there's 6 different ways that you could group two of those sides together. You could group the opposite and the adjacent. You could group the opposite and the hypotenuse. You could group the adjacent and the hypotenuse. You can group the adjacent and the, so you could keep going and you can match them all up. I'm only going to deal with 3 of them. Here's the 3 I'm going to deal with. I'm going to take the opposite. I'll just use O and H now instead of OPP and HYP. Is that all right?
Yep.
OPP. Back in the day, that used to be a song. Did you know that? Okay. All right. So you know that? All right, anyway. See, I know. I'm up with that stuff. So watch. So instead of that, we're going to write O. Watch what I'm going to do. I'm going to give you 3 different ratios, and these are the important 3 that we're going to discuss in here. So one ratio is the opposite to the hypotenuse. So I want to compare the opposite side to the hypotenuse. That's one ratio. Here's another one. I want to compare the opposite to the the adjacent to the hypotenuse. The adjacent to the hypotenuse. And here's another one. Actually, let's scooch this over just a little bit just to give myself some room. Okay. Sorry. So now I'm going to compare the opposite to the adjacent. Opposite to the adjacent. And you say, why in the world am I going to do that? Well, it's a good question. We're not really going to know this until a little bit later. All right,
Doesn't matter which ones you do, though, right?
Well, these are the big 3. Okay, these are the 3 that we're going to compare. We're going to compare the opposite to the hypotenuse, the adjacent to the hypotenuse, and then the opposite to the adjacent. You could get 3 more, but just by doing it the other way. You could go hypotenuse to opposite, couldn't you? Hypotenuse to adjacent and adjacent to opposite. But we don't go that way right now anyway. All right, we're just going to do these 3. Now look. If I was to compare those sides to each other, each one of these comparisons is pretty important, and they actually get their own name. All right? So when you compare the opposite side to the hypotenuse, that particular ratio, they give it its own name, and they call that the sine of the angle. Sine, S-I-N-E. All right? So the sine is a special word. I'm not sure where they really got that from, but it's a special word that represents what? It represents the opposite side divided by the hypotenuse. Do you see that? And then, yeah, we'll get it to us. Yep. Now, there's another word that represents the adjacent side to the hypotenuse, and that's the cosine. Right. And sometimes, depending on how much you did in Algebra 1, sometimes Algebra 1 teachers actually teach a little bit of this. Right, and this one is the tangent. Right, the opposite over the adjacent is called the tangent. Okay, good. All right, so that's the tangent. Now look, instead of writing the words all out like this, we shorten it up just to 3 letters. So for sine, we write S-I-N. Now it looks like sin, but we don't say sin. Okay, not because sin's a bad thing and we shouldn't talk about it. It has nothing to do with that. All right, listen to me. It just is a shortened version of sine. It's not much shorter. It's only 1 letter shorter, but these get shorter, right? And it makes it a little bit easier. So what we do, which angle were we talking about in this first triangle right here?
A.
A. So what I do is I take the sine of A. So if I just said, what is the sine of A? Well, what do? You look here and you say, okay, the sine is the opposite side divided by the hypotenuse. So let's pretend we knew the opposite side was 5, and we knew the hypotenuse was 7, let's say. Is that all right?
Yeah.
Then what would the sine of angle A be equal to? Be 5 over 7. Exactly right. So it's just a nice little shortcut way of representing the ratios of two sides of a right triangle. That's basically all it is. Okay? It's just one word that represents it. Instead of me saying, oh, please take the ratio of the opposite side of the hypotenuse. Instead of saying that, we just say, take the sine of the angle. And that automatically tells the person, oh, that's the opposite over the hypotenuse. It's 5 over 7. Make sense?
So the sine is always the opposite over the hypotenuse?
That's correct. The sine is always the opposite side divided by the hypotenuse.
That's what I meant when I
Okay.
said, does it have to be that way?
Oh, I didn't hear you say that, I don't think.
And you were like, yeah, for right now. Right now.
Yes. There are other ones, like, I'm not going to worry about, I'm not going to. Watch, cosine. Watch, the cosine of an angle. Now, the cosine isn't a variable, right? The cosine isn't like, solve for cosine. It's not. The cosine is just a word that talks about a certain ratio between two sides. That's all it is. You understand that? Cliff, you getting all this? Okay. Anybody got a stick? Tap him with a stick when he starts dozing off, okay? So watch. The cosine of the angle is the adjacent over the hypotenuse. Tell you what, let's put some numbers in instead of the O and the H and all that good stuff. Is that all right? Yeah, let's do it anyway. I should have. So 5 and 7. What do you think this? Let's call this side 6. Is that all right? All right, so 5, 6, and 7. Now, this is not a real triangle, okay? Because there is no 5, 6, 7 triangle. I'm just putting those numbers in there just, I don't know. I'll tell you what.
No.
Sorry. I'm sorry. It's not going to be that big of a deal. Let's just make it a little bit more. Let's say that's 3. This is 4. And what would this be? That would be 5. Is that all right? It's not that big of a deal. I can't. Because it's not a right. You can't have a right triangle with 5, 6, and 7. So I couldn't do that. So let's make it a triangle that actually does exist. Okay? So watch. What would the sine of this angle be? It would be what? Opposite over hypotenuse, so it's what numbers? 3 over 5. What would the cosine of this angle be? It's the adjacent over the hypotenuse. It'd be 4 over 5. Good. What would the tangent, now watch, tangent, we just put tan of angle A. What's the opposite over the adjacent? Is 3 over 4. Okay? You with me on that? So, well, if I ask for the sine of the angle. Now look, if I say, what is the sine of angle A, what would you tell me? Just 3 over 5. That's it. What would if I ask for the cosine of the angle, it's just 4 over 5. If I ask for the tangent of the angle, it'd be 3 over 4. Okay? Does that make sense? Tell you what, this is not really to scale or anything, but I'm going to do this anyway. Let's say this is 5. Let's say that's 12, and let's say it's 13. Okay? Now watch this. Listen. What would the sine, I'll just kind of squeeze it in here. What would the sine of angle B be equal to? What is the sine? It's what? It's opposite over hypotenuse. Which one is opposite angle B? 12. Which one's hypotenuse? 13. Good. What is the cosine of angle B? It's the adjacent over the hypotenuse. So it's 5 over 13. Good. What is the tangent of angle B? What is the tangent? It's the opposite over the adjacent. So here's angle B. 12 is opposite. And what's adjacent? 5. So what is it? 12 over 5. And you look at that and you say, well, big deal. Who cares? I compared two numbers together. How's that going to help me? It will help you. I promise you. And I'll show you here in just a minute. Okay? Don't worry about it. That's all right. I'm going to show you. Okay, look. Let's use those easy numbers again. Actually, I'll tell you what. What did we say before? Let's make this like, I don't know, 23 degrees. And let's make this side like 5. Okay? Remember what I said we were going to do? We were going to be able to solve for x and y. Remember I said that? Let me show you how we're going to use that trig stuff in order to solve for this. Everybody watching me? Okay, listen. Shh, don't talk. Just listen. Thank you. So here's the angle that I know. Well, I could figure out this angle too. I could use either one of these angles, but this is kind of like angle A, right? So if I wanted to solve for this, what is this side to angle 23? It's adjacent, right? What side do I actually know? Dion, wake up. This is important right here. What side do I actually know? I know the opposite. So listen. Shh, don't talk. What do I know and what am I trying to find? I know 5, which is opposite, right? I know x, which is adjacent, and y would be the hypotenuse, okay? Let's say I'm trying to solve for x. So which trig function am I going to use in order to solve for x? Use opposite, because I know the opposite, and I'm trying to find adjacent. Which trig function uses opposite and adjacent? It's the tangent, opposite over adjacent, right there. I'm going to show you quick, don't let me forget, a quick way to remember that. We'll do more of this tomorrow, don't worry, okay? Because I want to really spend some time on this. So what would we use? We'd use the tangent. The tangent of what, though? Of the angle 23, right. We always take the tangent of the angle. Is equal to what over what? 5 over x. Okay? Now we got to solve for x. Now tangent of 23 is a number we can actually put into our calculator and get a number for it, okay? So how would I solve for x? I'll just show you real quick. We're running out of time. I want x on the top. I don't want it on the bottom. Okay, so what I'm going to do is I'm going to multiply this side by x. Why would I do that? So it cancels out. And then I got to multiply this side by x, correct?
Yeah.
So look what I have. I've got x times the tangent of 23 equals what? That cancels out, right? The x's cancel out. No, the x's cancel out. So it's just a 5 over here. The x's canceled out. Now, the tangent of 23 is just a number. It's something I can put into a calculator and I'm going to get a decimal out of it. So how can I get rid of something that's being multiplied by x? I divide, that's right. So I divide by the tangent of 23. I know I'm going pretty quick right now. We'll do more of this tomorrow. No, I don't. I want you to actually put it into a calculator. Okay? On these, I do want you to use a calculator. Watch how we do this. 5 divided by the tangent, watch, tangent of 23.
Wait, what button was the tangent?
The tangent button, the one that says tan. Okay, so 5 divided by the sorry, but that's what how else was I supposed to answer that? Watch, 5 divided by the tangent of 23. Hit equals, and there it is. It's 11.8. So guess what I just found? Whoops, not 18, 11. I actually found this side. I found the length of that side, didn't I? Remember, before today, I would have never been able to find that side. Now I'm able to find it. It's 11.8. Okay? Now we're running out of time, so I'm not going to do the hypotenuse. We'll do that tomorrow. You can write it down. Let me show you a quick way to remember this. We'll get to it. Watch. Look at this. The sine is the opposite. Watch. Sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is the opposite over the adjacent. Okay? Now watch. I'm going to make it a little easier. Instead of sine equaling like this, I'm just going to shorthand it. Does that make sense to you? Sine is what? Opposite over hypotenuse. C is the cosine, which is adjacent over hypotenuse. The tangent is opposite over adjacent. Now, do you see this thing right here? It kind of makes a word. It's a made-up word, but it sounds kind of cool. We say SOHCAHTOA. SOHCAHTOA. So if you say that a bunch, SOHCAHTOA. Sounds kind of like a Indian name or word, like SOHCAHTOA, or like a Japanese name or something like that. Right? So you're ready to fight somebody. Right, you're ready to fight somebody, you're like, SOHCAHTOA. You know? So anyway, that's what it is. That's an easy way, listen, shh, settle down. That's an easy way to memorize, okay, what these trig functions are. And you're going to want to know this. This is very, very helpful. Say it again. Let's say it together. 1, 2, 3. SOHCAHTOA. One more time. SOHCAHTOA. Right. We're going to do more with this tomorrow. And I'll give you a worksheet tomorrow. I was planning on giving you one today. But I think I've got a little bit more to teach. Okay, so I'll give you one tomorrow. And I won't give you homework tonight.
No homework.